Let's open Windows Explorer and create a folder for housekeeping. So I've created mine in E colon, and under computer vision, I have created basic image processing. And inside this, I have created an image folder where I have kept a hillview.jpg image file for this video. So I'll link this image down below in the description box so you can follow along with me. Going back to basic image processing folder, we'll open our Jupyter notebook folder over here. Copy the file path and in start type Anaconda prompt. So we'll be working base environment. So let me open this path in Anaconda prompt. So this is my E drive. So first I'll type E colon and then press enter, and here I'll type cd space and I'll paste the file path, Control V and press enter. And here, so if you are following my previous videos, I used to do conda list and see whether the packages are installed. Now this time we will not use conda list, we will use a Jupyter notebook, and we will import our libraries over there. If the libraries are not installed, we will install the libraries from Jupyter notebook itself. All right, so this is a new thing, and there are multiple ways to install libraries. So this is the second way to do it. So I'll type Jupyter notebook, press enter, and this is our Jupyter interface, and we have created image folder which can be seen over here, and inside this we have a hillview.jpg file. Let's go back to our root interface, and here we will open our Jupyter notebook. So click on new and select Python 3. So first I will name the file, so I'll click untitled and type basic image processing, press enter. The next step is to import libraries. So I'll comment it first. Import libraries, and the OpenCV library is named CV2. Press shift enter. So as you can see, our OpenCV module is not installed. So first we'll install it. So click on import libraries and press escape A to insert one cell above. And then you can type exclamation pip install OpenCV Python. Now sometimes the file name are not very intuitive, so you can always Google it. So you can type in the web browser pip install OpenCV, press enter, and the first search will be pypy.org. Click it, and here you can see the installation command. You can copy it from here, so I've already typed it. Then press shift enter to run it. So it gave me some warning, but it is successfully installed. Now I can run import CV2. So I'll press shift enter. So as you can see, it has executed it properly. Now we load our extension. So first the command, and then with the percentage sign, type load, press escape. So you'll get a help, and then nb underscore black. Press shift enter. So it has properly executed. If this is also not installed, you can type with a space nb dash black. Let's see what version we are running. So type print and under parenthesis cv2 dot 2 underscores, type version. You can press tab for auto completion and press shift enter. So you can see at present, at the time of shooting this video, I have 4.8.0 as my OpenCV version. The OpenCV functions that we will use can be categorized as follows. The first is reading an image, second displaying an image, the third one will be modifying an image, and the last will be saving an image. So the first one is reading an image. So I'll just mark down escape 2, and then here I will press shift enter. To begin, we need a function for reading an image. The only function we'll be using for this task is cv2.imread, and it requires two arguments. The first one is the file name. So under parenthesis and in quotes, we'll type first image, which is our folder, and press tab, and then our file, JPEG file, that is hill. You can press tab again for auto completion. And the second argument will be the flag for specifying what mode we want to read the image in. So there are three flags. The first one is cv2 dot in caps imread underscore unchanged. You can press tab again for auto completion. When the image is read, it is important to consider the image format. For example, if the image is a PNG file with a transparent background, it will be read as BGRA. A stands for alpha. Alpha channel is something which controls the transparency of the image. If the flag is not used, the image will be read as BGR by default with blue, green and red channels. However, it is essential to note that when dealing with transparent background, the image should be read as BGRA, not BGR. OpenCV commonly uses BGR mode by default, but for transparency, we need to consider BGRA mode and not RGB. Now you must have noticed that I am using BGR instead of RGB. The reason being OpenCV images are read in BGR format because when OpenCV was developed, BGR format was widely used by camera manufacturers and image software providers. So if you have noticed in my PowerPoint presentation, I have mentioned BGR instead of RGB. So coming back to our Jupyter notebook, we'll add some space over here. So the second flag is cv2.imread.grayscale. So I'll just copy paste it over here and change this to grayscale, type G and press tab. So cv2.imread underscore grayscale is being used to read the image in grayscale format, which means the color will be converted to shades of gray. And the third flag is cv2.imread underscore color. I'll just copy paste this command again. This flag is a default flag. So if you write like this, it will read as cv2.imread.color as a default flag. This interprets any image as a color image as it is. So I'll assign a variable to all the three imread functions. Press Shift Enter. Now I'll check the shape of all the three images. So I'll type image underscore unchanged dot shape. So this is three-dimensional. So in our previous video about NumPy arrays, the command we discussed are mostly the same. However, there is one key difference. We now need to include an additional dimension in the shape of NumPy array. So the number of channels, that is 3. This is a RBG image and it has 3 channels. So the new shape of our NumPy array will be first one the rows, then the number of columns and then the channels. So if you see our PowerPoint presentation, we can see the first will be width, then height and then our channels over here. Let us quickly see the other shapes as well. So image underscore grayscale dot shape. Now this is very important. When you convert the image into grayscale, it becomes two-dimensional. Alright, so there is no 3 channels over here anymore. Similarly, if you convert any image into 2 dimension, then also it becomes a grayscale image. Alright, I will show you an example later in this video. Just remember this, and this is very important. Alright, now we'll just call an image to see what output it gives. Press Shift Enter. And you can see it gave me a batch of arrays. As I said earlier, that computer sees the image in the form of numbers as seen in the PowerPoint slide over here like this. So every pixel over here has converted into a number. At present it is BGR format and later we'll convert this into RGB. So to display an image, we'll come to our next point, that is displaying an image in OpenCV. To display an image, we have an option of 2 libraries. So OpenCV and Matplotlib. I personally use Matplotlib, but I will show you both. Let us insert some cells to write a code. Now using OpenCV, we have 3 primary functions to display an image. The first one is cv2.imshow. This function requires 2 arguments. The first argument is a string that specifies the name of the window where the image will be shown. So you can consider this as a title also. So we'll type Hillview, you can name it anything you like. And the second argument will be the actual image that we wish to display. So in our case, it is image original. Once the cv2imshow function is executed, we can proceed to use the cv2.waitKey function. This function determines the duration of time the control should remain on the window. If the intention is to move to the next code block after the user presses a key, 0 can be specified. Otherwise, a numerical value can be provided to indicate the number of milliseconds the program should wait before proceeding to the next code block. For instance, if a 10 millisecond wait is desired before moving to the next code block, you can type 10 instead of 0. To ensure proper visibility of the display window, it is important to call cv2waitKey function. However, even after moving to next code, the window will remain open and may appear unresponsive. To close all display windows, you can use the CV2 destroy all windows function, which does not require any argument. It is advised to close display windows once they are no longer required. So I'll change a wait key argument from 10 to 0 before executing the code. So I'll press Shift Enter and you can see the image has opened. So now you can press any key to close this window. In order to display an image, we have to write these 3 lines of code again and again. So why not convert this into a function? So let us create a function for calling an image. So this 3 line of codes will be there. All right. So let us type def imshow underscore cv2 and then we'll pass some arguments over here. We'll see in a sec. Press colon, press enter. The Jupyter notebook is smart enough to indent it. Now we'll copy the code from here, paste it here, indent it properly, and then we have to give this 2 arguments every time. So we'll pass this in a function. So the first one will be title equal to, and I will keep a blank quotes over here so that we can pass any title depending upon the image, and then we'll call the image itself. All right, so here I will type title. So whatever title you will give here, it will come directly over here, and then we have to call image here. All right, so it has now become a function. Press Shift Enter. So there is some problem over here. Let's see what is the problem. All right, non-default argument follows default argument. Okay, so we can give image equal to none. So when before calling this function, so by default the image will be none. Okay, press Shift Enter. Now our function is executed properly. Now try to check our function whether it is working proper. Imshow CV2. It takes 2 commands. Press Shift Tab to get a help. So first one is title. So give under quotes hill view, and then the next one is image. So our image is image original. All right. So you can press Shift Enter and you can see our image has popped up. To close this window, you can press any button on the keyboard. Now we'll see how to display an image using matplotlib. So I have some unwanted cells over here. In order to delete it, I can press escape and DD again and again so that it will delete the unwanted cells. And here if I want to insert new cells, I can press this button, or I can press escape and B again and again to insert cells. So displaying an image using matplotlib also has 3 functions. So the first one is plt.imshow. Plt is the short form for matplotlib, and here we'll pass our image. Press Shift Enter. So as you can see, our matplotlib is not installed. So we can go in our import libraries cell and we can type import matplotlib.pyplot as plt. This function can also be written as from matplotlib import pyplot as plt. Both are same, so we can use one of them. So I'll just comment it. All right, and then I will press Shift Enter. So as you can see, matplotlib module is not installed. So again, go back to our installation library and type matplotlib. Again, if you have doubt on the name of installation, you can Google it, but this is the proper one. Press Shift Enter. So matplotlib is successfully installed. Now you can run this command of import libraries. Press Shift Enter. So you can see there is no error over here, and then you can go back to your original cell where you were working, and then you can press Shift Enter. Now there is a new error. Name image is not defined because this is not image, this is image underscore original. All right, so now press Shift Enter. So it has executed correctly. Now there is a problem over here. If you notice, the matplotlib is giving us the image in BGR format, not in RBG format, where cv2.imshow function, if I run it again, you can see it is giving in proper RGB format. So what happens over here is OpenCV automatically converts BGR image to RBG image. But in matplotlib, we have to give a command of conversion function so that this image is visualized properly. So in the next section of this video, when we will cover color space, we will convert this image from BGR to RGB. So let us complete this displaying option. As I have said, we have 3 functions. So the second function is plt.title, and then you can give any title over here. I'll name it hill view, and then the next will be plt.show. All right, press Shift Enter. So you can see the same option. but after giving plt.show, if you have noticed, there was something written over here which got disappeared. Let me show it again to you. So this got disappeared when we wrote plt.show. So now let us convert this command into function. We'll write def imshow underscore plt, and then let us see what argument it will take. Type colon, press enter, so it will indent it automatically. Then we'll take plt.imshow, all the three commands from here, indent it properly, and then here it will take image. So I'll type image over here and pass it in a function argument, image equal to none, and here it will take a title, and that also I can pass it into a function as an argument. All right, press shift enter to execute it, and it has executed properly. Let us check it. So imshow underscore plot, press shift tab for help. So it will take title as the first argument and image as second. So we'll give title first, hill underscore view, and then our image name. So image original, right? So press shift enter. So it is still giving me a BGR format, but we will convert this later. Now let us see the shape of our original image. So shape of an image. So we'll type image underscore original dot shape. So we have 848 as a height, then 1280 as our width. This is our channel. So at present we have BGR. So this is our RGB channel or BGR channel, you can say. In order to make it more informative, you can type print, and under F string you can type height of image, image original dot shape, and then you can slice it. So this is the first index. Index starts from 0, so you can give 0, and if you press shift enter, it gives error. Why it gives error? Because you have not given a completion quotes over here. All right, so press shift enter again. All right, so height of an image is 848. Similarly, you can give width and your channels over here. So 0, this will become 1, and this will become 2, and here will be width, and this will be depth of image color channels. So if you press shift enter, you can see height of image is 848, width of image is 1280, and depth of image is 3 color channels. So now we have completed reading an image and displaying the image. So now we'll have a look on modifying an image. So in modifying an image, let's explore some image manipulation functions that can be used to modify an image. We'll focus on functions that are designed for the following tasks. So first one is converting an image color space. The next will be splitting an image into various channels. The last one will be merging channels from a split image. So this is very interesting. So let us start with converting an image color space. So for converting a color space in OpenCV, we'll use cv2.cvtcolor function, and it takes two arguments. The first one is the image we want to convert. So in our case, it is image original, and the next argument is the conversion flag. In our case, we will convert this from BGR to RGB. So we'll type cv2 dot in capital letters color, press tab, color underscore BGR to RGB. All right. So we can assign a variable as well, image underscore RGB underscore 1. Because this is the first method, there are three methods to convert the image from BGR to RGB. So this is the first method, and now I will call our imshow.plt function over here. So the first argument is title, hill underscore view underscore 1, and our image. So this time I'm not taking original image. This time I'll be taking the converted image. So this is our converted image name. I just paste it as an argument and press shift enter. So you can see now the image is converted. This image was here. So this was in BGR format, and now it has converted into RGB format. So this command, you can assign this in our function as well. So instead of image, we can copy that function over here and just give this name as image. So if I run it again, press shift enter, so it has executed properly. Now if I execute this, wow, you can see the RGB image instead of BGR. So you can put this in function as well. All right. Now we'll see the second method to convert the image from BGR to RGB. So first let me show you the image shape. So image original dot shape, press shift enter. So the first one is height, width and our channels. So we'll swap this channel. So it is very simple. Call your image underscore original, then under square brackets. The height will be same, so just give a colon, then press comma. The width will also be same, so type colon and comma, and then we will reverse this from BGR to RGB. So just give two colons and -1, so it will reverse your channels from BGR to RGB, and then you can call your imshow function. But before that, assign a variable to it, image RGB2 equal to, and then call the function. So you will see this is converted now into BGR format. Why? Because in the function you have hard coded this conversions. So here it converted from BGR to RBG, and here also we have converted the image again. So it is now giving you the BGR format. In order to get this image proper, you can comment this and write plt show function again and just give your image. All right. So if I press shift enter, over here, it will convert again to BGR, and now this will convert into RGB. So I hope you got the point, because we have done two conversions, one in the function and one over here. Now we look at HSV color space. HSV stands for hue, saturation and value. So the only difference is hue only takes the value between 0 to 179. So it has 180 intensity points. Similarly, saturation takes 256 and value takes 256. So the conversion is very simple, cv2.cvt color, and then we'll call the image first. So our image is image original, and then we'll call our color space. So we are converting BGR to HSV. So cv2.color, press tab, color underscore BGR to HSV. All right. And then we will call a imshow function. Also we'll assign a variable, press shift enter. So you must see the HSV format, but this is not the proper one. Let's go back to our function of plt imshow, and here we will comment this, and we'll remove the comment from this. Indent it properly, press shift enter. Now if you run this, you can see the proper HSV image. Let us see the shape of the image also. So we have three channels, and this is our width and height. In order to convert our original image into grayscale, you can type cv2.cvt color, and in parentheses you can give our image name. So in our case it is image original, and then again you will give your color space. So cv2.color, press tab, color underscore BGR to gray, press tab. All right, so assign a variable to it, image underscore gray equal to, and then we'll call our imshow function, press shift enter. So this is our grayscale image. Now you remember I told you that any grayscale image has only two dimensions. So let us check that also. Image gray dot shape, press shift enter. So you can see grayscale image has only two dimensions. To split the channel, we can utilize cv2.split function. This function only requires one argument, which is the image that needs to be split. It will then split a list of three channels, which are blue, green and red. To check the shape of all the three channels which we have split, we can type the respective commands .shape and press shift enter. So now the different channels got split into different shapes. So the width and height will remain the same, only the channels will get separate. The next step is to see the image of the different channels separately. To begin with, we'll display with blue channel. And press shift enter. So you can see the blue image. Now you will say, Farhan, this is blue image, but it is showing as a grayscale image. Why? Because if you see over here, the blue only shape has only two dimensions. And remember I said earlier that if there is only one dimension, then it will give a grayscale image. Now in order to see blue color in this image, we have to give green and red dimensions as 0. So as you remember in my NumPy array video, I have shown you how to create a zero array matrix. So let us create a matrix of 0. So going back to our PowerPoint slide, we can see that the height and width will remain the same. So we can take height and width from our original image. So we can type image original dot shape. So now we only want the height and width. So we can give a command like this in square brackets :2. So you can see now the dimensions are gone and only we have height and width. Let us create a zero matrix. Let us assign a variable. 0 is equal to np dot zeros. So now it will take a shape. So we have a shape over here. We can copy this, paste it over here, and then our d type will be uint8. So let us see the zeros dot shape. Press shift enter. So it gave me error because numpy is not called. So we have to import numpy library. So let us go to our import library cell, import numpy as np, press shift enter. I've misspelled it. NumPy. I'll press shift enter. Now it has successfully executed. Let me go back to my cell. And now if I press shift enter over here, it gave me error. Okay, uint is not spelled correctly. All right. So shift enter. So now you can see. So our np.zeros has a dimension 848 by 1280. To merge channels, the cv2.merge functions can be utilized. So it requires a sole argument, which is a set of comprising three channels, that is blue, green, and red. So once executed, it will provide you the merge image. So the blue channel is blue only. Then we are assigning zeros to it in order to see the blue values only. And now the red channels will also be 0. So I hope you are getting my point. And now I press shift enter. So it gave me error. Merge takes at most 2 arguments. Okay, so it has to be in square brackets, and then I will assign a variable also, blue 0 0 equal to. Now it ran successfully. Let me call blue 0 0. So imshow plt. Then it will take title blue 0 0. You can name it anything as you like. And then blue 0 0. So press shift enter. So you can see now that after assigning zeros to green and red channel, we got the blue image. Similarly, you can do it for red also. Let us see over here. So we'll copy this command, paste it over here, put a cursor over. If you want to change these two values together, you can put a cursor, press Control, put a cursor again back over here. I'm pressing delete, and then I can type red. All right, press escape to clear the cursor, and then you can press shift enter. So you can see the red image also is in black and white because it has only one dimension. So you can copy this, put it over here, press Control to put cursor on three areas. Then you can type delete, and then this is which one? Red, I guess. So now this is red, red, and here for the blue you will put zeros, and for red you will type red only. Press shift enter so you can see the red image. I hope you are getting the point. If only there is two dimension, you will get a grayscale image, but you have to put zeros in other two dimension to get a image of that particular color. All right, so now you can do it for green as well. Control V to paste, press Control to get cursors, then you can delete and you can type green, press shift enter. So this is blue, red, and now we have green also. And similarly, copy this one, paste it over here, press Control to put multiple cursors, press delete. Now type green, press escape. Now where is your green channel? In the middle. So type green only, and red only, put zeros. Press shift enter so you get your green channel. I hope you are getting the point. Also now I will show you the third way to convert BGR to RGB. So first split the image. I'll copy the command from here. Alright, so this is the same command, and then I will merge it. So image underscore RGB underscore merge. This is a new variable equal to cv2.merge, and now you will merge in reverse. So the first one will be red only, then green, and then blue. And now we cannot call the plt.imshow function because it will again convert it from BGR to RGB because we have hard coded that in the function. So let us call imshow cv2. So it will take two arguments. The first one is title. So image RGB merge, and then we'll call our image RGB merge. All right. So press shift enter. Now the final step of saving an image. To save an image, we'll utilize cv2.imWrite function, and in matplotlib we have plt.imsave function. Both of these functions take similar two arguments, so let us write it. So the first one is plt.imsave, press tab, and it will take two arguments. The first one is the file name, so we'll give image underscore save, and this will be in quotes, so because it is a file name, dot extension png, and then we'll call this image. All right, press shift enter. So this will be saved in our Jupyter interface root file path. So now we'll see cv2.imWrite function. So it takes the same argument, image underscore save. Now I'll put 1.png, and I will take original image and press shift enter. So it will return true. True means the file is created. And here you can see the image. So this video became too long. I hope you have learned something. This is actually the ABCD of the computer vision. So if you don't know this, you will not be able to do any computer vision project. So this was it from my side. Please subscribe to my channel, and I will see you in the next video.